You ever wonder what it really takes to land one of those top-tier AI jobs? Well, instead of just guessing, we're going to do something a little different today. We are going to reverse engineer one. We're taking a real job description for an AI/ML tech lead at a major media company and building the exact project that would get you hired. So let's break this thing down and see what it takes to build a project that actually lands you the interview. Okay, so here's our game plan. First, we need to understand the huge problem that media companies are wrestling with. Then, we'll unpack the specific toolkit an AI lead needs to solve it. After that, we'll sketch out the blueprint for our project, take a peek at the code that makes it all tick, and finally, we'll talk about why this whole thing is such a game changer. So let's start with the big picture, right? Media companies are practically drowning in video. I mean, every single minute, hours and hours of new stuff gets uploaded. And just making sense of it all is this massive, urgent problem. And that brings us to the real technical challenge at the very heart of this job. How does an AI actually watch a video? And I mean, really understand it? It's not just about seeing a bunch of pixels. The AI needs to do what our brains do instantly. It has to connect the words someone's saying with the objects on the screen and the whole vibe of the scene. It needs to get the full context. That right there is the complex problem this project is built to solve. And this is where our hero steps in, the AI/ML tech lead. Their whole mission, their reason for being, is to architect the systems that can finally understand, search, and moderate this tidal wave of video. They're the ones building the solution from the ground up. So, what kind of skills does this architect even need? Let's open up the toolbox and see the essential gear required to build this kind of sophisticated AI. First things first, the core models. It's not enough to be a specialist in just one thing anymore. You have to be an expert in computer vision so the AI can see. You need natural language processing so it can read. And you need speech models so it can listen. But the real secret sauce? Mastering multimodal models, the ones that can process all of these senses at the same time, just like we do. And this brings us right to the heart of our project, something called Multimodal RAG. That stands for Retrieval-Augmented Generation. The best way to think about it is like an open book exam for the AI. Before it even tries to answer your question, it goes and retrieves cold, hard evidence from the video frames, the audio, and the text. This is so important because it makes sure the AI's answers are grounded in facts, not just making stuff up. Now, having a brilliant model is one thing, but making it work on a mind-boggling scale, that's a whole other beast. And that's where scaling and performance come in. We're talking about knowing all the tricks for GPU optimization to make the hardware scream, using frameworks like DeepSpeed to train these monster models without having to wait for weeks. It's all about speed and efficiency when you're dealing with this much data. And finally, you've got the MLOps infrastructure. This is kind of like the plumbing of the whole system. It's what keeps everything running smoothly and reliably. You've got tools like Airflow to manage all the data pipelines, Kserve to actually serve the model to users, and vector databases, which act like a super fast, specialized memory for the AI. This is the backbone that makes a cool experiment into a production-ready system. Okay, so we've got all the tools laid out on the workbench. Now let's see how we actually assemble them into a real concrete project. We're moving from the what to the how. And here it is, our mission statement. We are going to build a mini platform that can take in a video, understand it, answer questions about it, and even help moderate the content. This one project, if you build it, demonstrates that you've mastered that entire toolkit we just went over. So here's the project's workflow, laid out like an assembly line. First, we pull in a video. Then, we chop it up into its core pieces, the visual frames, and the spoken text. Now, this is where the magic happens. We convert all of that stuff into these numerical fingerprints called embeddings, and we store them in our vector database. That's the AI's long-term memory. Finally, we wrap it all up and deploy the whole system as a live service. And check it out, this is the specific tech stack we're using. These aren't just random abstract tools. These are the industry standard choices for each job. For instance, we're using Whisper for the audio transcription, Clip for the image embeddings, and Pinecone for our vector database. Building with these shows you know how to work with the best tools in the business. All right, time to get our hands dirty. Let's zoom in on the core code that powers this entire system. This is where all that theory becomes reality. Okay, part 1 is ingestion. You can think of this as the teaching phase for our AI. We're taking a raw video file and breaking it down into a structured format that our system can actually learn from and, more importantly, remember. So the key function here is embed and upsert. It grabs the text from the transcript and the frames from the video and runs them through these encoders. The encoders turn everything into vectors, which are basically just numerical fingerprints. Then we fuse the visual and text fingerprints together and upsert them, which is just a fancy way to say add or update, into our vector database. The big takeaway here is that we're storing a single combined memory of what the AI both saw and heard. Now for the other side of the coin. Retrieval. This is what kicks off when a user comes along and asks our AI a question about the video it just learned. The answer function, this is the beating heart of our RAG loop. First, it turns the user's question into one of those vector fingerprints. Then, it zips over to the database to find the most relevant video chunks. We call these hits. These hits become the context, which we then feed to a large language model along with the original question to generate a final fact-based answer. Simple as that. Of course, just building it once is never enough. We have to track our experiments, and that's where a tool like MLflow is absolutely clutch. Every single time our pipeline runs, it's like a new experiment in a lab. We log all the important metrics, like how fast it was or how accurate the answer was. This gives us a detailed history so we can see what's working, what's not, and how to make the system better over time. This is essential for building professional, reliable AI. And finally, how do we let the rest of the world actually use this thing? That's where Kserve comes in. This code essentially wraps up our entire RAG logic into a neat little class and fires up a server. Just like that, our Python script becomes a scalable, high-performance API that's ready to handle real production traffic. So, we've built the project. Now let's zoom back out and talk about why this is so much more than just a cool thing to put on your resume. The architecture we just built is a foundation. It goes so far beyond just a simple search bar. It unlocks brand new capabilities, like automatically detecting scene changes, generating smart summaries of really long videos, performing content moderation in real time, and powering a totally new generation of personalized content discovery. It directly hits every single key responsibility from that AI tech lead job description. So we've pretty much established that AI can now genuinely watch, listen, and understand video content. This shifts the entire goalpost from simple analysis to something way more exciting. The real question for the future is no longer just, hey, what's in this video? It's now, what should we ask the AI to create?